We're just opening the quiz right now.
Okay.
Yeah, and I'm moving over my applets. My normal probability applets are like at the back of my tabs. I have way too many tabs open. Okay.
Looks like we have a lot of data files.
Yeah, I usually don't open them until we get to the questions.
Yeah. Okay. Is everyone open, or do we need a few more minutes?
I'm open.
I'm still open.
I'm ready.
Okay. We'll give Sarah a minute or two. Why do you have to leave at 8:30 for your meeting?
Me, I have to leave at 8:30 to finish getting ready, and then I have to be there by 9. I can't be late for the meeting, and then I have religion right after.
Mm-hmm.
And then you have dance.
Yes, I still don't think I'm going to be able to go. I'll probably walk there with you guys, but I woke up this morning and I was like, I can't stay. Like, I just don't have time. Maddie and I were even talking about maybe trying to use our clean check passes today, but I don't know, because I think I could still get it done. It's just this research project is going to be so much, and I still have a geology presentation to do today.
Yeah.
It's crazy. So what do you guys think? Would you want to use the clean check pass today, or would you want to just wait?
I don't know. I feel like we need it. We need
I know,
the
that's the thing me and Maddie were talking about too. We're like, but we need so no matter what, we would have to still clean.
Yeah. I don't know. I think we should just clean it, use it next time.
Okay.
Okay, got it open.
Got it open. All right. So, question 2. Given a 90% confidence interval of 45 and 105 for the mean heart rate, which of the following is the best interpretation of this confidence interval? A, 90% of all people have a heart rate between 45 and 105. We are 90% confident that the true mean heart rate is between 45 and 105.
I think it's that one.
I think so too. Do we need to move on to the other options?
No.
Okay. All right. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go/no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go-no-go stimulus required the student to respond to a particular stimulus and not respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots for both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So, no, the distribution of the means of each sample is not normal since the sample size is small. No, the company needs to check that all the data combined is normal. Yes, the distribution of the mean of each sample is normal since the data have been distributed to be normal. And
It's that one.
I want to say it's that one too.
Okay.
Does anyone disagree with that?
I think it's probably okay. I feel like there were 2 requirements for this section, and like they're only talking about one, but I think it's probably okay.
Okay, so we'll pick C then. Okay, question 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval for the mean of differences using dependent samples. Confidence interval for U when sigma is unknown. confidence interval for the differences of means using independent samples, and confidence interval for U and sigma. I mean mean, sorry.
I think it's A. Because I'm pretty sure this is a dependent sample. We never talk about differences of the means unless they're talking about dependent samples.
Okay.
I'm
Yeah.
pretty sure, right, guys?
Well,
I think.
I think it's independent. Like, they don't need to rely on each other. They're separate studies. They're comparing the males and the females.
Yeah, it's just like, doesn't the fact that they pick a guy, like pick guys for the first one, like make it so that they have to pick girls for the second one? I mean, it isn't the specific people, and I agree with that. It's just like I said.
Well, they're not going to be matched pairs. There's no reason for them to be matched pairs.
yeah.
Right. So, do we ever talk about differences of the means when they're independent?
I can't remember.
I don't know. We could just try that. Because I agree that the specific data, like, there's no reason they would have to pick a certain girl.
So you think do we all think it's A, or are we kind of different?
We changed it to C.
To C. Yeah. Well, because if it were dependent, then population 1 would control exactly what is in population 2. And so either it,
Right.
like the
And
example
then
we had
also,
about,
wouldn't they have the same number if they were dependent? When they have the same number of samples, I feel like that was a thing.
Yeah.
You know, like there would be 20 guys and 20 girls.
yes.
Yeah.
Alright. We're good then.
Okay. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the saving account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3,402.08, 4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
Okay. A smaller margin of error. Okay, I think it's the last one.
Yeah.
I think it's actually a 99 instead of a 95. The reason being is because we count 30 as a large enough population to assume that that means the data is normal. So in order to get the confidence interval up, it would have to be a higher confidence interval.
We're trying to get a smaller margin of error. And I'm pretty sure for these lessons, the higher the confidence is, the larger margin of error we have to have. Because if we're 99% confident, we have to include a wide range of numbers to make sure that they're all inside our interval.
Yeah, that's what I remember.
Okay, yeah, that does make sense.
Mm-hmm.
Okay, so I guess we'll move on then. A factory makes the propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean lengths of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000. I can't remember.
Millimeters.
The lengths are known to follow a normal distribution, whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your own answers for the margin of error, lower bound, and upper bound.
Okay.
So is this
Fine. So this is gonna be the Z-score again because we have all of the information. So that was.
It's been a long time since I've done that.
Yeah, I mean it's on the review thing, so I have it up on the other page, but I also have it in my notes. So it's gonna be like the X minus the Z-score times the standard deviation, I think, yes, over n, square root of n. Let me make sure on this thing.
You mean x minus u divided by n times the square root? Wait.
No, z. It's, well, I mean, I don't know. I guess the equation for finding the.
Why would u be included in the z-score? I don't think I understand what you're saying.
Do they give us the standard deviation or sigma in this?
Yeah, well, they gave the standard. No, I
Good.
don't think they did actually.
Yeah, they do give it to us. So the standard deviation is 2. Wasn't the equation, you guys, for that just sigma over the square root of n then to get the sample, whatever you call it? So it would be 2 divided by the square root of 1,000.
No,
No,
1,000 is the mean.
The number 4.
4.
Yeah,
Yeah.
4. Alright, so that's 1. We should have known that, obviously. Okay. So that will be what, 1,000 minus the z-score for the z-score for a 95% confidence interval is 1.96. 1.96 times 1. So for the lower bound, I got 998.04.
That's what I got.
Bless you.
Thank you.
And what was the margin of error? Just 1?
Yeah, I think so. Because it should be 2 over the square root of n, and the square root of 4 is 2, so it's 1.
The margin of error is 1.
Wait. No.
Okay, I was really confused. I was like,
No, sorry, I thought Maddie was asking about how we got the number that we were going to multiply z by. No. So I'm pretty sure the margin of error, we have to use that little equation he gave us last time. So no, that's not 1. Okay, so the upper bound, I got 1,001.96.
that's what I got.
Alright, and so then now for margin of error, oh wait. Sorry.
So should do the
Either
upper minus the lower.
Yeah, I accidentally put them in the wrong spots. 998.04. And then 1001.96. It's the upper minus the lower divided by 2. Don't forget to divide it by 2.
Yeah.
This minus this divided by 2. So I got 1.96. Although that should be obvious, I guess. Unless we did something wrong, if that's the z-score and we only multiplied it by 1.
That's what I got.
I got that as well.
Sorry, my calculator was having a spaz attack.
No, you're fine. So, are we okay to move on to question 9?
Yeah, if everybody thinks we did it correctly.
I think
Sorry,
so.
I'm still doing the math.
Oh, okay.
I just need to go find the equations because I understand what we're doing. I just can't remember all these equations.
Also, I never gave you your notes, Maddie. I have them in my room for your story. I need to give them to you.
Yeah.
So I'm getting 1,000 for the lower interval.
What equation did you use, Sarah?
The x bar minus z times sigma divided by square root of n.
Yeah, I did the same thing, but I got the 900 something. So I don't know why we're not getting
Me
the
too.
same. I did the standard deviation over the square root of n before, and then I plugged it into the equation. Sometimes that makes a difference, like with the way your calculator will do it.
Okay.
And what did you put for the z-score, Sarah?
0.063.
So the z-score is going to be 1.96.
So when I plugged it into the normal probability app, it said it was 0.063. So how did you get?
Because I have a list of all of the level of confidence. So the z-scores for every level of confidence. So for like a 90% confidence interval, it's 1.645. For a 95, it's 1.96. And then for a 99, it's 258.
Me too.
I think I got the list off of a video one time.
So it's 1.9.
1.96.
Okay. Okay, so now I'm getting 998.04.
Yeah, I think that's what I got.
Okay.
Are we okay to move on, or do you want me to wait a little bit longer?
Okay, so the upper bound is 1001.96.
Yeah.
Yeah, that's what we put. And then the margin of error that we had was 1.96, which seems kind of weird, but I guess it's possible, so we'll see.
Okay. So, question 9. To assess the accuracy of a laboratory scale, a standard weight that is not known to weigh 1 gram. Oh, sorry, that is known. I was like, what the heck? That is known to weigh 1 gram is repeatedly weighed a total of n time, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean u and standard deviation 0.01 grams. How large would n be so that a 95% confidence interval for u has a margin error of 0.001?
We would have to use that equation for n that we had before. I think I have it right here. It was like, where are you, n? I also think we have it in the, oh, okay, here it is. So n equals the quantity of the z-score, the significant z-score, times sigma over m. I don't remember what m was. Margin of error, okay. And then all of that is squared. So we have to find the margin of error first, I guess.
It's given in the problem, Riley.
Okay, good. Perfect. So then we'll just plug that all in. We're doing, what's our confidence? 95%, so it's still going to be 1.96 times sigma 0.01 divided by margin of error 0.0001.
Okay, I got 196.
You have to square it though.
Oh, right.
Yep.
So with that, I have 38,416.
That's what I got too.
Okay.
Alright, are we ready to move on?
Yeah.
Why didn't...
Okay. The mean area U of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are, so just look over, I guess.
Alright.
Isn't it B?
You advertised to be 1,250. A tenant group thinks the apartments are smaller than advertised. So it's gonna be U equals and then U is less than.
Yeah, so I think it's
Yeah, so the last one.
So question 11, if we're all good with that. In a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance if the p-value is less than 8. Alright, question 12. A group of want to determine students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped, no outliers, and the sample variances are nearly equal. Can they use a NOVA hypothesis test to answer their question?
That's an interesting question. I wouldn't have thought to use ANOVA for this for whatever reason.
I wouldn't have either, but I can't tell you why.
Well, it's because it's multiple apartments.
Right. Hang on, I'm gonna go back.
What about that?
So I
So,
think it's, yes, it is enough.
So the requirements are that all the, wait, hang on. These are requirements. The data are normally distributed in each group, and the largest variance is not more than 4 times the smallest variance.
We do have a small random sample size, only 15.
But the data for each apartment are bell-shaped with no outliers. So does that probably means that they're normal?
Yeah.
Yeah.
And so then if the sample variances are nearly equal, then I would say if they're nearly equal, then the largest can't be 4 times the smallest because they're nearly equal. So then I would say yes.
Okay, so do we think it's C then?
Yeah.
Okay. That makes sense. Okay. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. The null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after a diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. The further study has determined the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. So the researcher has...
Yeah, so we're doing those errors.
I'm gonna find
I'm pretty sure I think this was a type 1 error, but I'm gonna find it. Okay, so in a type 1 error, you say that the null, hang on, you reject the null even though it's true.
Yeah.
So,
And then the type 2 error is that you don't reject it when it's false. So I'm pretty sure that she rejected the null even though it was true. So then wouldn't this be type 1?
Yeah,
Yeah.
I think so. Okay. Question 14. If the level of significance A is made very small, thereby the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
It increases.
Yeah. So it's A.
Okay. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation 0.17. The brand advertises that the mean nicotine content of its cigarette is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. And
I
then
don't want to test it.
no one has.
No. And this is a weird question anyways.
So when I
Yeah.
checked this earlier, because so the confidence interval 0.05 with the number 1.5, 1.53 is less than the 0.05.
Wait, you'll have to actually create a hypothesis test. Like we need to find the z-score or the t-score and find the p-value, because you can't look at the significance level and compare that to the sample.
Okay.
So like we have to find the z-score for this by using that equation probably. Let's see if we have everything. We might not have all the information. Let me do that. But I just nicotine content is actually higher. Yeah. Yeah, I think we need to find it. Let me find that equation. Also, I actually have to leave.
Okay.
Let me just see if I can find it really fast. I think it was just our original equation. Yes, guys, for finding the z-score of wasn't it just like the sample mean or the regular mean minus the sample mean, and then that over the standard deviation divided by
Square root of 1?
square root of n? Yeah.
Maybe.
I think that's right.
And here it is. Yeah, that's how to find the test statistic. It's just that we don't have u.
Well, it says the brand advertises that the mean nicotine content of its cigarette is 1.5.
Okay, there we go.
Yeah.
Okay, thank you.
So, remind me the order. It would be.
It's 1.35 minus 1.5.
Okay.
And then there's that divided by the quantity of 0.17 divided by the square root of 100. Yes. So the z-score I got is 1.7647.
That's what I got.
And so are we agreeing that this is a z-score problem, not a t-score problem?
Yeah, because it has all
Yeah.
the information. Okay.
So 1.647.
So that's larger than the level of
Also, this
Wait, you
is
got
a
what, Riley?
white tail test. For the z-score
Yeah.
or for the p-value? For the z-score, I got 1.7647.
Okay.
So for the p-value, I got 0.0388.
So,
That's what I got.
So then we
I can't hear you. What?
We would reject the null then, if that's the correct value.
Yeah.
Alright, people. Now I have to be out because I gotta go to that meeting. I'll have to finish things on my own, but thanks for doing half of it with me.
Yeah, no problem.
I'll see you all later.
Okay, bye, Riley. Good luck. Tell me what it's about because I'm dying of curiosity.
I'll tell you. Bye.
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 Okay, 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So, we're dealing with differences, and we're dealing with two groups of people.
I think it's independent samples t-test.
I think it is as well.
Yeah.
Okay. Question 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
I would say dependent sampling, the last option.
I think so too. 'Cause
Yeah.
yeah, I think it's the last option. Okay. Looks like we're gonna have to pull out SPSS now. Okay. I'm just pulling it up real fast and I can read that question. Okay. I'm just going to read over the question real fast. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded in blah, blah, blah. The researcher would like to construct a 95% interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? I don't think we need SPSS for that. I'm going to figure out.
I think it's confidence interval for you when sigma is unknown.
Yeah.
When sigma is unknown?
Yeah.
Okay, yeah. Alright. So wait, what kind of test are we conducting here? Because we need to figure that out. Is this one sample test?
Yeah, wasn't it?
One sample t-test, maybe?
I think so.
Since we're saying
Yeah.
sigma is unknown, and that's the kind of test we use for that. So
Yeah.
we'll do one sample t-test. Okay. We don't put a test value in this one.
We don't have anything to put in.
Right, that's what I thought I'd do. Okay. We have to determine the margin of error for this confidence interval. So it would be the upper minus the lower divided by 2.
Yeah.
Okay. I'm going to go ahead and do that. I don't know if you're still opening it, Sarah, but we'll wait for you.
I've got it open.
Okay.
I got 2.02452.
Okay, 1 second. I am just about to enter in the numbers. Sorry. My calculator's kind of dumb sometimes. 7.
Okay, so for the, I got the lower bound is 11.168.
Yeah.
Yeah, you're right. Goodness, if I can get my calculator to work.
So we find the margin of error by
Subtracting the upper from the lower and dividing.
dividing by 2.
Yeah. Yeah. What did you get again, Annie?
Rounded, I got 2.025.
Yep, me too. Let me know when you get it, Sarah.
That's what I got too.
Okay, cool. We'll move on then. 2.0. Okay. So just go ahead and input the lower and the upper, which we found out that we all have the same for. So 11.168 for the lower. And the upper is 15.217. Okay. Did everyone write down their answers for 20 and 21?
Yeah.
Okay. So it looks like we're opening up another one as well. But I guess we should figure out what they're asking of us before we open that up. So a random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data is recorded. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles Group 1 and Hummers for sale in New York Group 2. Create a 95% confidence interval of mean listing prices between the two cities. So
I think it's C.
Independent?
Yeah.
Yeah, I think it is.
Okay.
Okay, so just let me open up my other one. Okay. Sorry, it's still opening up for me. So your mean independent sample t-tests. Oh wow, that's a lot of options. So it would be the test variables would be the price and the mileage. What would the grouping variable be?
Hold on.
Sorry, it's just a lot to take in. I'm trying to figure it out.
So it wouldn't be the mileage. The mileage has nothing to do with this.
Right, you're right. So it would just be price and the test variable. And
Oh, you know what? We have to
you have to redo something.
Yeah. You have to
code.
automatic recode.
Yeah.
Okay, so for the lower bound, I got negative 423.158.
I'm still working on getting there.
Okay.
Here. So what are we recoding?
The
You have to
city.
recode the city.
Okay. I'm sorry, it's just Okay, city. Okay, and now we can analyze. Compare means. And
You got what, Sarah?
Negative 423.158.
That's not what I got.
okay.
Oh, wait. 423. Never mind, it is. I was looking at the other one.
Oh. Yeah,
Sorry.
so remember that we can't assume the variances are...
Right, we used the one on the bottom.
Yeah.
Okay, so what is it? I'm sorry, mine isn't working right now, so I might just ask you guys.
The negative 423.158.
Okay. And what's the upper?
It's 5417.256.
Okay. Probably question 25 is the last one I'm going to be able to do with you guys because I have to go.
Okay.
Okay, so I'll just read it out loud though. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups. A control with no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured, and the data was recorded.
I'd say it's ANOVA.
What? ANOVA?
Yeah.
Where the Kimball building is?
Right behind.
Okay, thank you. I love you. I never go there. Like ever.
It's the one with the financial aid office.
Okay, good.
And
Yes,
all
thank
of it.
you.
Yeah.
Okay.
Okay, sorry, what did you guys say?
ANOVA?
Okay.
That makes sense to me. Okay. So it looks like you guys have about 7 questions left.
You'll have to stop the broadcast and then we'll
That's
just
one
keep
thing
working.
that sucks. Yeah, I would have to stop the broadcast.
That's okay.
I don't think he's gonna make a big deal out of it. Hopefully not.
No, it's fine.
Okay. Well, good luck, guys.
Okay.
Bye.